In this slide, we would like to talk about supervised learning and subcategory of supervised learning. As we said in previous session, there are three types of machine learning methods. First, supervised learning that we will be discussing in this lecture, and we'll talk about classification and regression methods and difference between them. Classification algorithms such as KNN, SVM, that we will talk about them in the next session. Also, we will talk about some regression methods such as linear regression and support vector machine for regression. The learning problem from data is used in situations where we don't have any analytic solution. And we have to learn and build a model based on data. The basic premise of learning data is to use a set of observations to uncover an underlying process. Therefore, we have to create a predictive model to use data for solving a problem. For example, there is no analytic solution for weather forecasting, and we have used the previous data from recent years to predict and forecast the weather for future days. To this aim, researchers build a predictive model for solving this problem. Another problem is like the face recognition that we talked about in previous session. In order to create a predictive model, we have 3 steps. Step 1, sample data. For creating a predictive model, the first one is collecting information and data for related problem. For example, if we want to create a model to recognize dog and cat from images, we have to collect images from cats and dogs. So, data is information about the problem that you are working on it. Step 2, learning a model. In this step, a model learns from the collected data. There are so many methods to create a model that we introduce some of them in this course. In this lecture, we describe a model based on supervised learning. As I mentioned to you, the supervised learning, or the main objective of supervised learning algorithm, is to take some data with a non-relationship and to create a model of those relationships. So later we will discuss about supervised learning algorithm. Step 3, making predictions. After building a model, we should analyze the performance of the model in other data that doesn't use for building a model in training phase. You see the flowchart? The flowchart to create a model and predict shown in the right of such slide. For example, we have to train the data, then give the trained data to algorithm in order to create a model. We don't need to keep the training data as the model has summarized the relationship contained within it. The reason we keep the model learned from the data is because we want to use it to make prediction. In this example, we use the model by taking measurements of images of dogs and cats, of which don't know the cat and dog. The prediction may not be perfect, but If you have good sample data and robust model learned from that data, it will be quite accurate. The most common type of machine learning is to learn the mapping y equal fx to make prediction of y for new x. What is fx? What is x and what is y? Fx is target function. X called as an input variable and y called as an output variable. So if you look at this flowchart, we have to predict the y as an output variable in terms of quantitative and qualitative. For the section quantitative, it means that you have to do measurements or count recorded as a numerical value like height, temperature, etc. For qualitative, you have ordinal and normal. In ordinal means that possesses a natural ordering. For example, shirt sizes. For nominal, just name the categories, material status, gender, etc. In conclusion, we have to give X as an input and we have to mention Y for the target function with the help of Y. The Y can be categorized as a quantitative and qualitative. Here we have a regression example. In this slide, figure with 10 points generated from a scene function with noise is shown in here. The goal of regression model is approximate a mapping function f from input variable x to a continuous output that is, in this example of output, sinus function. You can see the mapping function that are shown in this figure. For example, you have a data set, 10 points generated from scene function with noise, and also this is the continuous output. Another example of regression model is used for stock market forecasting. To solve this problem, we have to use previous data for training and validation. And finally, we test the model with early data. You look at the training data, which is shown in blue color, and for the validation, you use the yellow color, and for testing, you use with the green color. Our target for stock market prediction is look like this figure. Classification predictive modeling is the task of approximating a mapping function f from input variable x to discrete output variable y. The output variable are often called label or categories. The mapping function predicts the class or category for a given observation. For example, for classifying and recognizing cat and dog from images, we need to images with label dog and cat for each image in the training phase. Then, in testing phase, we ask the model to recognize the input image. If you look at this picture, the computer or the program will check the images whether it is dog or cat in training phase. This is dog, this is cat. And later on in testing mode, you give a new picture like dog, and the program or predictive model will ask what is it. In terms of classification, we call categorical output. In terms of regression, we call continuous output. And then in testing phase, the model will train, and then we will give you the exact or accurate result. For example, this is a dog. Let's compare regression and classification methods. In regression, we have continuous labels or quantitative. And for classification, we have categorical or qualitative label. For example, in regression, converse situation where y is continuous. We want to predict the value of the rainfall in 6 months. This is the regression problem. And for classification, another example is, will the rainfall be up or down in 6 months? This is the classification problem. We have some more example in terms of Python programming, and we will teach you how to run the regression and classification. If we look at the regression problem, a regression problem requires a prediction of quantity. Multivariate regression problem, we have a problem with multiple input variables. For time series of forecasting problem, a regression problem where input variables are ordered by time. If we ask you to do some time series forecasting, you have the input variable, but the input variable are ordered by time. And we ask you to do multivariate regression problem, you have multiple input variables. Regression is the task of predicting a continuous quantity. This is the summary of regression. For the classification, we have a classification problem requires that examples be classified into one of 2 or more classes. For classification, we have binary classification problem, multi-class classification problem. In binary classification, a problem with 2 classes, very easy. In multi-class classification, a problem with more than 2 classes. We have many examples we will give you. Classification is the task of predicting a discrete class label. In the next session, we will talk about classification method, and we will use Python to implement them. We have a lot of examples using machine learning in Python with real application.